Let's start with our first topic, that is electric charges and fields. Okay, so basically electric charges. Now, before we start with electric charges, let's talk a little bit about our atom. Okay, we have already discussed about atom in class 11, second chapter chemistry. Okay, and we will discuss about that thing again in physics also in the second part, but right now let's focus only the structure of atom. An atom is made up of two things. One is a positively charged nuclei, and the second part is electrons. Okay, we know this nuclei contains further two more things, protons and neutrons. We will not talk about that thing. We'll right now focus on electrons. So if we have an atom, this atom is made up of nucleus and the electrons are revolving around this in a particular orbit around it, right? Now what is important here is these electrons are itself having a charge, and this charge is our negative charge. Okay, negative charge. Now, how will you define a charge, sir? A charge can be defined as an intrinsic property of a charge. Let me define the charge. So, charge can be defined, it can be defined as the intrinsic property of a given object. Okay, any given object, the intrinsic property, like mass. Unlike mass, it is also a scalar quantity. We will go into the properties of charges, but charge as a, okay, simplest definition we can talk about that it is an intrinsic property of a given object. Okay, and there are two types of charge basically. One is negatively charged and another is positive charge. Now positive charge is mostly contributed by protons. Okay, so positive charge, we can say it is because of proton, but in first part textbook we will talk about positive charge means lack of electron. If you remove electrons from a particular system, okay, that system will become positively charged. Similarly, if we call a negative charge is basically excess of electrons. Excess of electrons. Okay, so if any object has a large amount of electrons, we call it as negatively charged. If we remove electrons from any system, we call it as positively charged because there are lack of electrons. Let's take it a simple example, okay, from chemistry part only. Like for example, sodium has, what is the atomic number of sodium? 11, right? Now we can write the electronic configuration as 1s2, 2s2, 2p6, right, and 3s1, right? Yeah, so here how many number of electrons are there in a sodium atom? 11. And how many protons are there inside the nucleus of a sodium atom? Sir, 11. Now if we remove the outermost electron from this 3s1, it will get into a stable state, right? So if you remove this electron from the outermost shell of sodium atom, what you left with? You left with 1s2, 2s2, 2p6, right? So one electron is already gone. But what about protons? So protons are still 11. So overall charge of sodium atom becomes positive. So we write it as Na plus. When you remove an electron, the overall charge of the sodium atom becomes positive, right? So this is called as positively charged atom. So positively charged atom doesn't mean that you are adding protons. It simply means we are removing electrons. So always remember, positive charge in the whole first part textbook, we will deal with such situations only. Like if you take a battery and there is a positively charged end and there is a negatively charged end of this battery, then positively charged means lack of electron, negatively charged means excess of electron. Okay, any doubt in this part? Now let's go into some particular properties of the charges. But before that, a very important statement which is given in class 7th also, I'm repeating again, and that statement is very important, that like charges repel each other. Very, very important. Repel each other. While unlike charges attract each other. attract each other. Very, very important property. Okay. Now the question is, what is the unit of charge? So let's write the unit of charge. We will go into dimensions later on. Right now, in the first lecture, we are just focusing on the unit. So unit of a charge is simply coulombs. So Coulomb is a unit of electric charge. Okay. Very, very important. So how do you write it? We write it as capital C. Be very careful, capital C, because I'll tell you what happens if you by any chance write small c. There will be an issue later on when we write another unit. So keep in mind, capital C is the unit of charge. Okay. Let's talk about the basic properties of charge. Let's go into the properties, and very important, many times asked in exams, what are the basic properties of charges? So let me just write here, basic properties of electric charge. Okay. So let's talk about basic properties. There are different properties. The first property is additive in nature. Additive nature. Sir, what do you mean by additive nature? Additive nature simply means that the total charge on any system can be added directly. So you can say that if a system, let me write it in a formal way, if a given system contains n charges, Q1, Q2, Q3, so on till Qn, then the total charge of the system. How do you write the total charge of the system? We write the total charge of the system as Q1 plus Q2 plus Q3 plus and so on. We can directly add them. No vector addition, no resultant formula, directly addition. Because charge is a scalar quantity, we will write it in another property. Okay. So this was the first property. Let's move to the second property. So second property, let me write here. So second property is conservation of charge. Many times asked question in exams, conservation of charge. Let's understand what is conservation of charge. So though you can write it like they used to write in class 9th or 8th standard, like charges can neither be created nor destroyed, they can be transferred from one system to another system. That is another way. But since you are in 12th standard, so write it properly in a proper way. So proper way of writing conservation laws is the total charge of any isolated system always remains conserved. This is our conservation law. Now, what is the meaning of this statement? Let's talk about this. Let's say if this is a system initially, and it contains a total charge of 9 coulomb, let's say. If you break it into, let's say, 3 pieces or 4 pieces or 10 pieces, so if you break it, I'm just assuming that I'm breaking it unevenly with 3 pieces. Here it is 1 coulomb, here it is 4 coulomb, let's say. Then how much charge will be left in the third piece? It will be 4 coulomb. So total charge initial of any system will be equal to always the total charge final. Very, very important for numericals for this chapter as well as next chapter. The difficulty level will rise in the next chapter, but there it will be frequently used in case of capacitors also. Okay, that we will make use. So this is actually first lecture, but first lecture, this part will be very important for the upcoming chapters. So total charge initially for any system will be equal to the sum of all the charges finally. So here it is 1 coulomb, 4 coulomb, 4 coulomb. When you add them, the total will be 9 coulomb. Understood? Okay, so here these are the two properties of charges. We'll move to the next one. So the next property, which is very, very important, and the numericals questions will be based on that, and that is called our quantization of charge. Quantization of charge. Very important for numericals. Will be used in all the first three chapters, even later, but first three chapters frequently it will be used. Okay, this property, and very important for statement as well. So it says all free charges is always integral multiple of a basic unit of charge denoted by E. So all the charges in this universe are always an integral multiple of E. Sir, what do you mean by integral multiple? Very important statement. Integral multiple means, like if I enter a classroom, let's say I entered a classroom and I say that how many students are there in your class? Somebody said 10. That's fine. Somebody said another classroom I went, somebody said it's a 20 number of students we have in our class. Okay, fine. But I went to a third class. There a student is saying, sir, in our class we have 22.54 students. Now that's not true. Exactly. You can't have a student in pieces, right? Or in fractions. So that is very, very important. The total number of charges are always integral multiple of electrons, which means you can have always integral value of number of electrons. You can't have fractions. You can have 5 electrons, you can have 20 electrons, you can have 30 electrons, you can have 100 electrons, you can have 500 or any number you can think of, but you can't have half of an electron, you can't have a 3/4 of an electron, like that. So the total electrons are always, the total charge is always Q equal to Ne, where N is the integral multiple, N is an integer, like you can have a negative that will give you the negative charge. If you can have a positive charge like -5, -4, -3 and goes to infinity, and it starts from minus infinity to plus infinity, you can have. Okay, but infinite will be not, so you will take a numerical value which will lie between a minus infinity to infinity. So n will be an integer. Sir, what about E? What is E? So E is a basic unit of electronic charge. And what is the basic unit of electric charge? The charge of an electron. What's the charge of an electron? 1.6 into 10 to the power minus 19 coulombs. Now be very careful. One electron has this charge. Charge on one electron. Charge on one electron. Charge on one electron is how much? 1.6 into 10 raised to minus 19 coulomb. That's the charge on one electron. Great. Now the question is, what is the how many? Question is, let me write first question. First question is, how many electrons? How many electrons are present in 1 coulomb of charge? Now be very careful. 1 coulomb of charge is different from 1 electron. 1 electron consists of 1.6 into 10 raised to minus electron, minus 19 coulomb. But what about 1 coulomb of charge? 1 coulomb of charge. For that, we will make use of this formula. So what's the formula? The formula says the total charge Q equal to Ne. What about Q? Sir, in the question, Q is given as 1 coulomb. And what about E? Sir, 1 E is nothing but 1.6 into 10 raised to minus 19 coulombs. What they are asking, sir? They are asking the value of N. Great. So let's do one thing. Let's use the identity and find N. N is nothing but Q by E. And Q is nothing but 1 coulomb upon E is 1.6 into 10 raised to minus 19. And that is nothing but exactly 6.25 into 10 raised to 18 electrons. Sir, do we have to remember this value? Yes. Be very careful. As a beginner, many students, they take this value 10 to the power 18 as minus 18. Don't know why, but just keep it in your subconscious mind that 10 to the power 18 will be positive because numbers can never be negative. Yeah, that way, or you can think of the 10 to the power 18 is a the number of electrons, how can it be negative, right? Charge on electrons can be negative, but the number of people, number of chocolates, they can't be negative in a sense, right? So 10 to the power 18, 6.25 into 10 to the power 18 electrons are transferred when you say that 1 coulomb of charge is transferred from one end of the wire to another end. Okay, so that's a very crucial value you have to keep in mind. Clear? I'll remove this. Great. So this was one part. Let's see another part, that is our, let's increase the difficulty level. Let's say the question is, find the total positive charge present in 36 grams of water. 36 grams of water, you have to find the total charge, positive charge. Now be very careful. Let's see here how to solve this situation. So keep your pen down, focus on the screen and understand this problem, right? So that later you can do it on your own when I'll put some questions on the screen. So here, 36 gram of water. First of all, we don't know how many molecules of water are there in the 36 gram of water, because if you know the molecule, you can count the positive charge. Let's talk about water a little bit in terms of chemistry. H2O is the chemical formula for water. And in H2, in each hydrogen atom contributes how many electrons? One electron is there in hydrogen atom. So how many atoms are there? So 2 atoms are there. So how many electrons are contributed by H2? So 2 electrons. 2 electrons. And what about oxygen atom? So oxygen atom contains 8 electrons. Be very careful. Oxygen is single atom while hydrogen are 2. So that's why 2 electrons. So total electrons present. Total electrons present will be how much? 10 electrons in each molecule. Be very careful. Now we don't know how many molecules are there here, right? So 10 electrons. And here, if total electrons are 10 electrons, first of all, we will find the molecules. To find molecules, we need a concept of chemistry, that is number of moles. So number of moles to calculate, we should know that number of moles is mass in grams over molecular mass, right? Mass in grams over molecular mass. So, sir, is the number of moles equal to number of molecules? No, be very careful with that. That's not equal. Number of moles will have a specific number of molecules that we will see later on. So, mass in gram over here is how much? 36 given mass. And what about molecular mass? Now that you should know from chemistry. Otherwise, you can see 18. 18 grams is our molecular mass of water. So we found that for this 36 grams of water, how many 36 grams, how many are the number of moles? 2 moles. Yeah. So number of moles here is, let me just write here, number of moles is 2. Now if number of moles is 2, let's figure out our molecules. Each molecule, now be very careful, each molecule contains how many each mole contains how many molecules? Number of molecules, exactly, number of molecules in 1 mole is equals to 6.022 into 10 to the power 23. Now in 2 moles, it will be 2 into 6.022 into 10 to the power 23. So that will be the total number of molecules present in 2 moles of a given water. 36 gram of water, how many molecules are there? This number. Now each molecule contains how many electrons? Sir, each molecule contains 10 electrons. So how many protons will be there? So 10 only, 10 only, because it's neutral. When you're drinking water, it's neutral, right? Because the number of electrons are equal to number of protons, right? So number of protons, or let me write here, total number of protons present in these 2 moles will be 10 into 2 into 6.022 into 10 to the power 23, right? Now that we can solve later on. So this is the total number of proton. Is it the total positive charge? No, sir. Why? Because each proton has a particular charge. So total positively charged or positive charge will be 1.6 into 10 raised to minus 19. That's a charge of a single proton into total number of protons. That is 10 into 2 into 6.022 into 10 to the power 23, and that will be in the terms coulombs. So that is the total charge. You can multiply that and you will get the total positive charge. So sir, water 36 grams, or ideally speaking a cup of water contains this much positive charge. Yeah. So what about, sir, why we don't feel shock? Because the total positive charge is equal to the total negative charge. So overall charge of the water will be neutral, right? So this is the way we calculate the total charge. Understood? Hmm. Yes, you can take a screenshot. Okay. Now, related to charges, we have one more thing, that is our charge distribution, or how the charges are transferred. Okay. So we'll just initially start with a very basic idea. Later on, we will make it a little more complex in the second chapter. But right now, we'll just focus on what happens if you take two charged object and you touch them. Okay. So let's say if we have one object like this, okay, and this contains any charge q1, okay, initially on this object, and another metallic object or conducting object that has a charge q2 on it, okay, and if you touch them and separate them, be very careful, we are touching them, okay. So we also call it as charging by conduction. We will talk about different types of charging, okay. So right now we are talking about charging by conduction. If you are taking two charges q1 and q2, and if you are touching them, so let's say you touch them, something happens between both, and when you separate them, now when you separate them again, what happens is the total charge on the first object will become q1 plus q2 whole divided by 2, and here also q1 plus q2 whole divided by 2. So basically the charges redistribute themselves. Charges redistribute themselves, okay, and equally they redistribute. They don't keep like separate, they just keep equally. So you add both of them and you divide it by 2, or simply the charge redistribution takes place like this. Understood? Now there are different types of charging, okay, like we can charge any object using friction. So let me just write, because they are simple definitions, like you must have done this in previous 8th or 9th standard. So the different ways of charging are charging by friction. So what is charging by friction? Charging by friction simply means, charging by friction means you are taking one object and you are rubbing it on another object, so that the electrons, they simply lose, one object loses the electron, another one gains it, okay. Overall charge conservation takes place, but this happens due to friction. So this is called charging by friction, okay. Like if you take a simple scale and rub it on your hairs and it will stick the papers, that is our charging by friction. You can have another one, we call it as charging by induction. Now what is charging by induction? Induction simply means what? Simply means, like if there is a object, for example this is an object, okay, and we have a rod. Let's say this is a rod, and this rod is itself is a positively charged rod. So the charge on this is positive. What will happen? It will simply take negative, it will influence the negative charges present on the first object, okay, and it will repel the positive charge present on this. The negative charge will be attracted towards this positively charged rod, while the positive charge present on the sphere will be repelled by the rod, right? So what happens in this way, if I connect a wire from this to ground, all the negative charge will go from this to ground. So basically you can make this overall charge on the sphere as positively charged. So this is also called charging by grounding, okay. We will talk about grounding in the second chapter, you know. Yeah, that's what, attraction takes place here, but they don't stick together. This is very important about induction. In case of conduction, as you have seen here, what happens? The charges redistribute. So basically if you remove this rod, again the sphere will become neutral, because the total positive and total negative charge will be Same. So the influence is only there until the rod is there. It is like you are getting scared from a strict teacher in your classroom. Once the teacher enter the classroom, everyone is silent and they're doing their work. Moment that strict teacher goes out of the classroom, everyone, they redistribute themselves as they work. So it is like if okay, so when the strict teacher is teaching, everybody is looking at the board, focusing on what he is saying. But moment the teacher goes, the students, they redistribute themselves. Understood? So question says, if a body is negatively charged, then it has excess number of electrons, because more the negatively charged, more number of electrons. Okay. So we will talk about here. The correct answer is option A, excess of electrons. Okay. Let's move to the question number 2. So the question here says quantization of charge. What does quantization of charge implies? It simply implies that the charge on an object is always integral multiple of electronic charge. That is option D. Let's move to the third one. It says number of electrons present in 1 coulomb of charge, that is 6 into 10 raised to 18, or if you are given with 6.25 into 10 raised to 18, that is also fine. Okay, so even B is correct, and if you are given with 6.25, that's also fine. So they have approximated it as 6 into 10 raised to 18. Charge on 10 kg electrons will be. So basically, first we have to find what is the mass of one electron. So mass of one electron has a mass of 9.1 into 10 to the power minus 31 kg. That's the mass of a single electron, right? So first we will have to find that how many electrons are there in 10 kg. So number of electrons in 10 kg will be equal to 10 over 9.1 into 10 to the power minus 31, right? So I'm just approximating it as 9 instead of 9.1. So if you divide 10 by 9, you will get approximately 1.11 into 10 to the power plus 31. These are the number of electrons in 10 kg. Now each electron, one electron has a charge of 1.6 into 10 raised to minus 19 coulombs, right? So total number of electrons we have how much? 1.11 into 10 raised to 31. So total charge that would be 1.6 into 10 raised to minus 19 multiplied with 1.11 into 10 raised to 31, right? Now 1.11 into 1.6, that will give you approximately 1.77 into 10 to the power now 31 minus 19, that is nothing but 12 coulomb. So approximately option A is correct, 1.75 into 10 to the power minus plus 12, sorry, coulomb. That's our correct answer. Yes, our next question. Charge is a scalar quantity or vector quantity? Charge is a scalar quantity. That's correct. So let's move to our next one. Here. So in the process of charging by induction, the correct answer is there is neither loss nor gain of electrons by the object. That's the correct answer. Let's move to the next one. The amount of negative charge present in 72 grams of water. So first of all, what we will do is we will first find the number of moles. So number of moles will be equal to how much? 72 divided by 18. So from where you got 18? 18 is the molecular mass of what? So 18 and that will give you how much? 18 fours are. So 4 moles are there in our the 72 grams of water. So number of molecules will be, let's see, number of molecules. So number of molecules will be 4 into 6.022 into 10 to the power 23. That will be our number of molecules. So if this is the number of molecule, let me just multiply this. 6.022 will be 24.088 into 10 to the power 23 molecules are there. Now each molecule of water contains how many positive charge? They are saying no, negative charge. So how many number of electrons? Number of electrons which are total present in one number of electrons in one H2O molecule. Since the hydrogen is contributing 2 electrons and oxygen is 8, so total is 10 electrons are there. Yeah, so the total electrons will be Let's multiply the molecules. Total electrons will be equals to 10 into 24.0288 into 10 to the power 23. So that simply I'll increase the power. So 24.088 into 10 to the power 24. That will be the number of electrons, and the total charge, multiplying it with the charge of an electron. So total charge will be simply multiplying it as how much you got? 1.6 into 10 raised to minus 19 into 24.24, correct? So let's multiply 24.088 into 1.6, that will be 38.54 into 10 to the power 5, and that's our coulombs. So its correct answer is option B. It should be in coulombs. That's the unit.